Okay, I'd like to welcome you to the Petersheim Exposition, Interdisciplinary, and Study Abroad poster session. Jared, turn my mic off. I thought I had it off. Thank you. Sorry. Off? Okay, I'd like to remind the participants that this is a recorded event, and the link to the recording may be available by request and may be on the Petersheim website at a later date. Students will be presenting their research and their experiences. Each presenter or presentation group will come up to the front. They will have 5 minutes to present, and then there will be a 2 to 3 minute question and answer period. For those joining this event online, you may place your questions in the chat feature or raise your hand. Then when you're called on, unmute your microphone to ask your questions. Our producers today are Michael Supiez, Chris, and Jared Cicera. I'll be acting as the moderator who will remind the presenters when they have 1 minute left. If a presenter wishes to use their question and answer time to continue their presentations, questions may be placed in the team's chat and they will be forwarded to the presenter. The link to the team's meeting is also posted on the Petersheim Expo event calendar. Okay, would our first presenters please come up and introduce themselves and their topic?
Okay. Good morning. My name is Alexa Gall. And I'm Sophia Donnelly. And our project is based on the analysis of residual glyphosate that is found in foods and plants. So basically, what started our project was a lot of farmers and like the food industry uses a herbicide called Roundup. And in Roundup, there is a plasticizer called glyphosate, which is known to be cancer-causing. So for our project, what we did was we made an experiment using glyphosate and spiking plants over a certain period of time. And using that, we were able to see like if the plants took in the glyphosate or if they didn't. And that's how we measured whether whether the herbicide was like actually getting it into the food or not.
So for this project, we decided to use carrots due to the widespread consumption around the world. So for the beginning of our project, we had a control and experiment group for our carrots. Over a 6-week period of time, every other day, we spiked our carrots with our experiment group. We spiked them with glyphosate, and then the control group, we just did every other day with water. During that time, we watched our plants grow and see if there was any change due to the spiking in glyphosate. And then after the 6-week period, we continued analysis.
So what we used to spike our plants was so basically when we got glyphosate in our lab, it was in a powder form, and we needed to make that into a liquid form. So what we did was we took glyphosate, and over a while of trial and error, we found that it was only dissolving in a mixture of 50-50 hexane and acetone. So we used that, we mixed it together, and then we were able to come up with our solution, which that we did like 1 or 2 drops on the plant stems, like every other day that we'd water them, and that's what we used to spike our plants. And figure 1 you can see is our standard curve, which is basically our solution diluted in different ratios of water, and we use that standard curve later to compare it to our results.
So after the 6-week period, we took our plants and separated them into roots, leaves, and stems. After that, we dehydrated them for about a week, and then after that, we used our mortar and pestle to crush them up, and then we used a microfilter to put them in our tubes for the HPLC analysis. And then
So for our method, it took a while for us to come up with a method. We've only been doing this project for about a year, so yeah. And then if you factor in like plant growth and everything, but for our method, we used a bunch of trial and error and also some online resources to come up with the method that she just said, where we put it in the solution and then we ran it through the HPLC. And then for our results, there's not a lot of results because it was obviously it was very trial and error, but what we did was we ran our separated from stems, leaves, and roots through our HPLC, and what we took was we took the peaks that came out of the HPLC, and we take the peak area, and using our standard curve, we put the peak area of all those into, it came up with an equation to find the concentration of glyphosate in all those parts of the plants, and that's where we came up with our results there. So we did find that over our 6-week period that the plant did absorb the glyphosate. So it's still a very work in progress project, but yeah, we hope to continue with it in the future, and this is what we found. Yeah.
Like this particular project to research because we found that many people use glyphosate every single day, or the Roundup.
A lot of people use herbicides
The
when
herbicide Roundup to
around
either
their
kill
plants.
weeds, and we found that specifically in farms, animals are eating these grasses, they're eating these plants, and it can harm them. And humans, we grow vegetables, we grow fruits, and we found that people could be consuming these, and this can be cancer causing. So we wanted to see, like, in one specific vegetable, what is the concentration of glyphosate there?
No, we didn't look into that yet, but we could look into that for the future. Yeah.
Okay, great. Okay. Good morning, everyone. My name is Bianca,
Me, Ashley.
and today we're talking about our ideal project in the Dominican Republic. The issue we want to focus on is clean water access, especially in rural areas of the Dominican Republic. And here on the map, you can see in the lighter colors the rural areas of the country. The two main factors that are leading to these issues are climate change, with rising temperatures and increased evaporation rates, and socioeconomic factors. We can see that the Dominican Republic has a lot of economic disparity. In fact, the 34.4% of the population lives below the poverty line, and the 10% controls 40% of the whole national wealth. And the Gini index also shows a really shocking economic disparity. This water insecurity is leading to two main issues in the country, which are public health and the economy of the country. We can see on the map here, Mexico and Dominican Republic, that this is the managed drinking water in the households in rural areas, and the Dominican Republic stays between 40 and 50% of the whole households, which is a really low level, and that's why we want to focus on this issue. Another issue is public health. In fact, rural people are facing issues in having access to safe drinking water, and this is leading to a lot of disease, especially for children. Diarrheal diseases are the highest cause of death in the country. And only in 2023, there have been detected 88 cholera outbreaks in the country, which is a really high number that shouldn't be a problem in 2024.
So why rainwater harvesting? Obviously, our project is a proposal. We don't have any data to go along with our project yet, but we did want to provide some evidence for some other global successes with rainwater harvesting. In 2000, Brazil launched their 1 million rural cisterns project to demonstrate the effectiveness of rainwater harvesting, and by 2018, which is about 20 years, little less than 20 years into the initiative, they were able to prove that they can improve water access for millions, and this kind of creates a snowball effect of a bunch of other social and health issues. So why rainwater harvesting works? Rainwater harvesting provides a reliable source of water, especially during dry seasons, and it reduces the dependency on other contaminated water sources, which can lead to other health issues and waterborne illnesses. It's also been a proven cost-effective method, and while the Brazil launched their initiative on a very large scale, the Dominican Republic certainly could adapt this on a smaller scale, especially in a rural context. The PM1C project, as it's abbreviated, has had a substantial impact in improving water access on a household level. 1.2 million cisterns have been built and implemented, and which obviously reaches millions and millions of people throughout the country. The clean water is not only used for drinking and sanitary purposes, but also for cooking and cleaning, and slowly being introduced on an agricultural level. And the large-scale implementation has not only increased water access, but it's also increased an overall quality of life, especially in rural communities. This specific project helped over almost 630,000 families, and interestingly, the demographic was about 70% female, and this is likely because this is the demographic that is dealing with the issue at a household level, and it is slowly stimulating economic development in the region, increasing food security, and enabling a environmentally friendly and community-centered approach. And we have a little diagram here. I don't know if you can see it because it's kind of small, basically displaying how the water drips from, how the rainwater is collected, stored in the cisterns, and then used within the household.
Now going into Now going into the implementation of our rainwater harvesting system, which we plan to be methodical and inclusive. We want to begin with a thorough community assessment phase, where we would evaluate local water needs and engage with stakeholders to tailor our approach to each community's unique conditions and challenges. Following this, we want to move into the system design phase, where we take into consideration local climate, as well as roof sizes and water demand to ensure sustainability and efficiency. Then installation and training, which will be a collaborative effort involving local community members, empowering them with the skills necessary for ongoing maintenance and troubleshooting. This hands-on approach not only fosters a sense of ownership, but also builds local capacity, ensuring our project's long-term sustainability and viability. The impact of our project will extend beyond just providing clean water. We anticipate with the implementation of it, significant health benefits, especially due to the decrease of incidences in waterborne illnesses. Additionally, these systems will contribute to economic growth by boosting agricultural productivity that can be off-put by inadequate water supply. Furthermore, our focus on efficient design minimizes environmental impact and promotes sustainability. Through comprehensive community engagement and continuous education, we aim to address common pitfalls of similar initiative and enhance the long-term viability of our water systems. The graph that I included was from a Michigan State study, which showed that systems can have a lack of sustainability and long-term viability if continuous education and things that we have implemented different than other previous initiatives are not performed or followed through with necessarily as vigilantly. And then ultimately, this project is about empowering communities to improve their own lives in a sustainable and equitable way. I think that's it. We would want to initiate it first at a community level and see the demand that's necessarily needed per community. And then if further action is needed, we would obviously do that as well. It's kind of a trial and error. We wouldn't want to do anything too dramatic and then not have it be successful.
So obviously we don't have like an exact cost because the project hasn't been implemented, but like other sustainable development projects, we would seek private funding and then through organizations like NGOs. So the project was at a household level there, not on a community level. While there's not, I don't remember the exact statistics from the project off the top of my head. The agricultural level would be just not economic, but more at like a household, like sustaining like your own food sources. But I think the main response was that it improved a quality of life because people were able to have access to sanitary water sources for not only drinking, but also for cooking and for hygiene purposes.
We have another question.
So that was very informative. Thank you. I was wondering, how would you actually implement the, what is the project design so that you would actually be able to evaluate whether your project is actually working or not? So what kind of data are you going to collect? What kind of basis, on what information are you going to make the call?
So obviously, like, we don't have an exact method, but I think a big way to determine whether or not the project is actually working if there is a reduce in waterborne illnesses, but also if there is over obviously a long period of time, any increase in life expectancy, and also just an overall like measure of quality of life.
This is just a theoretical project, so we don't have a starting date. We were just imagining how this project would be effective in the country.
My name is Ren Haskins, and my project is on the effect of cyanotoxins on freshwater ecosystems. So for about the past 40-ish years, cyanotoxins have been one of the main causes of algal blooms around the country in slow-moving freshwater environments like lakes. So Cyanotoxins are released by something called cyanobacteria when they're exposed to too much sunlight in a very slow-moving water ecosystem, and the cells die and release a cyanotoxin, which can cause a very harmful algal bloom that can affect not only the environment itself, but also anyone that is exposed to it, like anyone living in the water, like a fish or a plant, but it can also affect the people swimming in it. So right now I'm working with Cupsaw Lake in Ringwood, New Jersey, who has formerly experienced an algae bloom of the sort and had to shut down the lake for it. What I hope to do right now is, this is a very early project. I'm about 6 months into it. I want to begin working with them and research different parts of the lake and test into the effect of what the cyanotoxins are doing and where they are at. So I want to look at about 9 different testing sites throughout the lake, taking into accountability where there are septic systems nearby and where there are different river inlets that are feeding into the lake. I want to test the plants, the sediment, and the water, and I'm going to be running them through HPLC and GCMS. And I'm going to see what the different levels of cyanotoxins are, to see not only where they're coming from, where there are spikes, where there are dips in the amount that there are, but also to see what different types of cyanotoxins are, because there are a multitude of different types of cyanotoxins that could be located in the water. And I want to see how they're affecting that, because there are many different types that can do very different things to the water. And as I said earlier, there have been algae blooms in this lake that have caused them to shut down. So as you can see from figure 1, they can cause something called eutrophication, where the algae takes over the environment of the lake and lead to a very lack of nutrients and oxygen within the water, causing the ecosystem to fall out of balance. So far in this experiment, I've been connecting with Cupsaw Lake, who's been working with NJIT to get a grant. And we are going to be testing the water for Cupsaw Lake as an alternative to working with a college or a lab company that would cost way more money on their front. And as a way, we're connecting mutually to begin testing with the, to begin testing with the cyanotoxins to see how the overall effect is. The future benefits of this, I hope, are to get a greater grasp on how everything is affecting the lake community and what we can do to further prevent or keep down the overall effects of this, because as a whole, the lake community would benefit from this project. The procedure so far right now is a little bit rocky, but I have spent the past 6 months researching how I can better it. I do hope to run these samples through the HPLC and the GCMS as a way to detect very small or large traces of cyanotoxins. I will be running this for a number of years with monthly tests that will be run and the data will be collected. So far, there is no data collected on this project, but I do hope to begin testing around September or this summer if possible. So far, the only listed algae bloom was in 2019, but that could have also been affected by the amount of care that's been taken by the lake, because they do have a lack of funding, so they haven't been able to send proper samples and get proper results very consistently. They are working currently with NJIT, but they don't have a direct program going on right now to prevent them. It's a community lake, so it's kind of like in like more like urban areas, how like there's a community pool. This is very similar to that. Yes, that's the main use for it. Yes. I'm going to be continuing this project over the course of my stay at the high school and hopefully pass it on to future people to continue this project for about 8 to 10 years to get proper results.
Good morning. My name is Thea Kumra.
I'm Isabella Bozan.
I'm Kira Welsh.
So our presentation is about the effects on silver on bacteria growth in beauty blenders. So beauty blenders are the sponges that people use to blend makeup into their skin. So the purpose of our study is to find out if the silver-infused beauty blenders actually reduce the amount of bacteria produced on the skin itself. So silver ions are known to be able to puncture bacterial walls and disrupt DNA replication cycles. This is often tested using a Staphylococcus strand of bacteria on the SAB agar. So we have seen some very sturdy results that Kira will go over in the conclusion, but now I'm going to pass it on to Kira for the method.
So for our method, we have 4 beauty blenders. 2 of them are standard basic brand blenders, and then the other 2 are infused with silver ions. We expose all the blenders to sterilized water. One of each different kind of blender is exposed to 0.5 milliliters of bacteria, and the other is exposed to 1 milliliter of bacteria. We let each blender sit for 24 hours before starting the extraction process, and then we squeeze the blenders and take the liquid to be poured into a petri dish to be left to inoculate for 48 hours in 28 degrees Celsius.
So as Kira mentioned earlier, as you can see on the top center, figures 1, 2, and 3, blenders 1 and 2 were our traditional non-silver infused blenders, while 3 and 4 were infused with silver ions. And as you can see in the photos, they did have significant difference in bacteria growth. However, we needed ability to quantify these results, so we determined that using traditional plate counting would be our best option. After the course of 5 trials, we collected the average number of colonies on each plate and calculated the standard deviation as well. Blender 1 had an average of 183 colonies, Blender 2 had an average of 240 colonies, Blender 3 had an average of 30, and Blender 4 had an average of 47. So as those results show, there was a difference. However, we wanted to make sure that our results were statistically significant. We concluded a 95% confidence interval to determine if it was statistically significant. We used the average plus or minus 2 standard errors of the mean, as seen in figure 4 on the middle, to determine if the interval between the normal and the silver-infused blenders would overlap. We found that they do not overlap, meaning our results were statistically significant. This strongly suggests that the results were due to the presence of the silver ions and not due to chance alone, thus supporting our hypothesis. It's important to note that we possibly could have sources of error, such as human error while measuring or contamination of our results. All researchers were required to wear gloves and goggles and to sterilize all materials and work area before and after starting any trial. After the completion of this research, we do need to discuss the future of the project. All 3 of us are seniors, so we will be unable to complete this research further, but all methods and data are going to be shared with future researchers in our program. So we have a few ideas for anyone who would be interested in this project. First, we would like to collect more data, as more trials and a larger sample size would help yield a better accuracy result. Another idea could be to use a different strand of bacteria rather than Staphylococcus epidermis. We could use a different strand and see how the silver ions affect that strand instead. And then another idea would be to determine if particle size of the silver ions plays an impact, because there is a study that studies if the size of the silver ion can lead to toxicity or not.
Yeah, so we use beauty blenders pretty much every day, and since they are sold at a higher price and advertised to be able to reduce the bacteria, we wanted to test to see whether or not that was true.
I don't believe that the blender's packaging has an expiration date, but they do advertise that it's infused with microbial silver to reduce bacteria growth, which is why we took on this project to see if their claims were valid. So I don't believe that it had an expiration date, but it did claim to reduce bacteria growth. So obviously you run a risk of cross-contamination, spreading bacteria from one person's microbiome on their skin to another person's microbiome on their skin. So that is one risk. We haven't fully studied different strains of bacteria, so we're only aware of the ones we studied, but I'm sure that would be another future that we could, of the project we could go through.
So we haven't fully studied the effects of the bacteria that grow on the skin. That could be something that could happen in the future, but we know that some of the bacteria that grow aren't the best for your skin. They can be harmful to the skin and the eyes.
Thank you. Oh, I was going to add on to what she said. Through a literature review, we saw that silver ions are commonly used in other products like laundry detergent and medicine. So we don't know fully if it has a level of toxicity on the skin directly, but it is helpful in certain concentrations for ingestion and stuff like that. Saw a question over here.
Yeah, so I was wondering, did you test on different brands of blender, or was it just one? Do you intend to just see whether they're as effective across brands?
So we only tested on a standard Amazon brand as our control, and then a brand called Eco Tools as our experimental group. That was the only brand we used, but like we said, we could test further on different brands to see if one brand uses a different particle size versus another brand that does. Thank you.
Good morning. My name is Claire Vargas.
I'm Juliana Focarino. I'm Jenny Whitmore.
So one of the rising trends we see in teens today is the overconsumption of energy drinks. From daily, people drink from like 1 to 2 energy drinks. And people think that this causes no harm to their body and just gives them a boost of energy. But in reality, the immense amount of taurine caffeine, and artificial sugars has been seen to cause a negative impact on people's health. So with our project, we are studying the effects of this chronic consumption of energy drinks on physical mice health and then like their behavior daily.
Yeah, so our method basically, we're taking 1 milliliter of energy drink through a pipette and force feeding it to the mice every day, Monday through Friday, just to see how it affects them and everything. We're also testing their weight and their water consumption to see if it like changes, because we think that the more sugar might make them drink less or eat more. So weekly we weigh them, and because it's shown in many articles that they might gain weight or even lose weight because they're more active due to the energy drinks. So we have 5 mice, 2 are control group and 3 are experimental, and only the experimental group is receiving the energy drinks over this 8-week period.
So we're going to be testing their behaviors through a series of different tests, and we're going to be putting them in this light and dark box, which we will do with both the experimental and control groups before and after giving them the drinks. So if they go and we put them in the lighter area first, and if they decide to explore into the darker side, it means that they have less anxiety since they are fully able to explore. And we're also going to be putting them in the maze. We're going to be leaving a treat at the end of the maze, and we're also going to be doing that before and after the drink with both the control and experimental groups. And we're going to be doing a time test for that to see how it affects their memory.
This project has just began, so we've only began exposure last week. So we do not have any solid results right now, but from, like we mentioned, literature research, we think that the mice will gain weight because of the artificial sugars in these energy drinks. And we also believe that the mice will become very stressed out because of this overconsumption of energy drink, and which will lead them to have like strange behavior, like sleeping patterns will change, which we will be monitoring via GoPro at night. We'll have it on the time-lapse setting and seeing if the energy drinks cause like a shift in their sleeping patterns, or like when they energize, like run on the wheels. We also recently received a grant, so we hope to draw their blood from the mice, which we will then use to see if their cholesterol or cortisol levels change. And we also believe that these levels will increase because of the consumption of energy drinks. That is all, if anyone has any questions. So originally we did like a conversion between like the size of a mouse from the size of the human, and we got that down to like 10 milliliters, but unfortunately we were having trouble like the mice drinking that much amount, so we did have to lower it to 1 milliliter. Yeah, so we have 2 phases of testing. The first 8-week period, we are going to test them on the Monster energy drink. And so that is the first phase. And then we're going to give them a 4-week rest period in between. And then we're going to test them on the other energy drink, which is just a Stacker's like energy shot, which is a smaller amount. And then we're going to see if it like they'll have the same effects or if it'll be different because of the different brands. So these drinks are targeted towards teens because, and like sports, people who do sports, because it does give them that boost of energy drink, energy for the day. So that's who usually consumes this drink. And it's, like I said, especially in teens, a lot of teenagers drink this.
No, because they were just having their normal activity running on the wheel, but also the amount that they consumed like the first day, because it was like it's very hard to get them to drink it through the force feeding. So the first day there wasn't really any immediate results, but we'll be able to tell in the future when they can actually fully consume it correctly.
Yeah, we do believe they'll become keen to drinking it just because the amount of sugar and like the flavoring of it, we think that they will like to drink it eventually.
Yeah. Good. Good. Hello, thank you everyone for coming. So our group chose to research a potential policy initiative in Costa Rica, specifically in the Central Valley region. So my name is Oliver Stacy. I'm joined here with my group, Jordan Robati and Gabriela Fernandez. And yeah, we're gonna delve a little bit more into some of the proposed initiatives that we had for the Central Valley region in Costa Rica. Before we do that, we would like to give you some background just on Costa Rica overall and the Central Valley region. So Costa Rica is a medium to high income country in Latin America. It is one of the leading countries in the region in terms of sustainability, in terms of economics, in terms of both poverty and other measurements. So for example, their GDP, as you can see on screen, is around 68 billion. Their Gini index, which basically is a measurement of inequality. So 100 would be perfect inequality, and then 0 would be perfect equality. So they're round about the middle. So there's a roughly pretty even distribution of wealth, and it's pretty average in terms of the disparities between rich and poor. The Human Development Index, excuse me, so the HDNI is around 0.809. So the HDNI is basically a measurement of life expectancy, income per capita, and general education level outcomes. So that basically measures how well the human capital is being utilized and how prosperous each people or each part of the people will be. The poverty rates are pretty low. The poverty rate here is being based on making around 5.5 US dollars. So 14% of the population in 2022 were making under that poverty line. But for the region, that is pretty good, especially in other Latin American and Caribbean countries. For their SDG rankings, they are one of the best. They're a leader in the region in terms of implementation, in terms of leading with institutions. Their incorporation with their parliamentary system is leading, especially in the region, because a lot of other countries don't incorporate some of their main government organs into the SDG implementation process. So as of right now, they are a leading country in terms of meeting their SDG goals. So going a bit more into the problem, Costa Rica is obviously, like I've just explained, a great country leading in many fields, but they still have problems with their current farming practices. Costa Rica relies a lot on farming. It's around 35% of their exports, mostly bananas and coffee. But as of right now, in the Central Valley region, they are using agrochemical farming fertilizers and practices which are causing damages and runoffs to the surrounding waters. They are basically harvesting and overutilizing the land that they currently have, which leads to it becoming arid and then them needing to expand further into the natural rainforest in order to clear more land, for farming. So you can see here on this graph, the giant lines of light green are shifting our agriculture, so all of that clearing for new crop plantations or things like that. Urbanization, as I'm sure many of you know, building cities, developments, roads, stuff like that. So that's that tiny, tiny little dark green that you see. And then that brown color you see is forestry. So that is clearing trees for like plantations, growing palm oils, anything like that. Those are generally temporary, where the forest is replanted or cultivated for resources. And so that's not really much of a concern compared to the clearing of land for expanded agriculture. So yeah, I'm going to hand it off to my colleague to talk a little bit about our solutions and how we'll go about them.
Sure. So while this is all a hypothetical implementation of policy, this is how we would go about solving this problem if we were to. So the majority of farms in Costa Rica are located in the Central Valley region. It's the best place for agriculture in the country. So we're going to look at the farms there if we were to implement this. So out of the 100% of farms there, we would break it up into thirds, so 33% of these farms in each group. And this would be done by random assignment to eliminate bias and to ensure that even though there might be differences in what the farms are growing, the implementations would be more or less the same. So our first group would be our control group. There would be no change there. They would continue farming as they have been and hopefully producing the same yields, if not more. And they would just be allowed to keep doing the practices they are. The second group would be our education-only group. So this group would receive training on sustainable farming practices such as soil health, crop rotation, eliminating the amount of pesticides they're using, and hopefully these farmers would be able to take this training and implement it and hopefully still produce the same yield in crops, if not more. And then our final group would be our education and high tunnel group. So this group would receive the same training I just mentioned, and they would also receive economic capital to invest in a high tunnel. So these high tunnels, they have already been implemented in some projects in the US and they've been shown to be effective. They're basically like greenhouses, but you can plant directly in the ground and they're not as expensive as greenhouses. So these tunnels provide a more controlled growing climate for the plants, so by that it extends their growing season, so they'd be able to produce more just because they'd be able to grow for longer throughout the year. It also allows more room to be taken advantage of because you can plant in the ground and in raised beds, so they would be able to just plant more automatically. And because the soil in this region tends to be rockier and often not the best, this would provide ways to avoid that struggle and allow them to plant with good soil and hopefully reduce pesticides and all that stuff since it'd be in a more controlled environment. So this final group would hopefully, with our goals, be the one to produce the most yielding crops and reduce the use of this agrochemical farming. So more sustainable practices will be in place, and it will also reduce the need to expand in farms and take up more of that land, cut down the trees and forestry because they'll have this added space to do that.
So how are we going to measure exactly if our intervention is going to work? So our central question, right, is how are we going to curb deforestation in the Central Valley region of Costa Rica? And you're going to see by these circles, it kind of represents the granular type of solution that we're looking at and how we're going to measure it. So at the largest circle, it's the percentage of adoption of organic farming methods post the intervention. So what the kind of externality that comes out of this program is how many farmers are going to actually keep using the high tunnels, are actually going to be doing drip irrigation, crop rotation, and so forth through the education. Then going further into it is the change in income of farmers using the organic farming practices, kind of going with the first one, to see if people are getting more out of it. So the high tunnels are supposed to increase the yield, and the education is, so are their income changing? The change in crop yields pre and post the intervention. So we want to look at, has the crop yields increased? From the USAID, for example, pulled something similar to this intervention, and they had dramatic crop increases in there. But our most granular and most important solution, what we're looking at in the Central Valley region of Costa Rica, is the change in deforestation rate. So as my colleagues here mentioned, in Costa Rica, many of the farms are using up the land and then getting trees and blowing them all down so they can get more land because the land is no longer arable. So we want to see if our intervention is going to be able to stop that deforestation through the use of high tunnels so that farming can be concentrated in one land and not increased or changed at all with deforestation. Thank you, everybody. If anyone has any questions.
Yeah, we didn't specifically look at exactly what the Peace Corps is doing, but we are aware that they have a big presence in Latin America and are able to teach those practices. So it might be something we'd be able to look into to work with the Peace Corps in terms of implementing that training and seeing what has worked for them, what hasn't yet. But it was not something we specifically researched, but if this were to be implemented, it'd definitely be an advantage we'd look into.
It's an interesting solution to have the growing season kind of extend and also the growing area being concentrated. But I'm wondering if you, by extending the growing season, is there, and I don't do agriculture, so this is a question, are you in danger of depleting soil minerals faster, and do you have a plan to kind of, have crop rotation or other aspects which is going to kind of take care of that problem?
Yeah, I know that with the high tunnels, one of the advantages we found was that it eliminates the need to find more land for soil rotation. So there would be ways of farming, probably with the raised beds, you can rotate just above or below in the ground where those crops could be planted. And because of the controlled environment, and you wouldn't need to use the same pesticides and chemicals in there, you wouldn't be destroying the soil the same way you would be if you're regularly farming. So by using the high tunnels, you eliminate the need for practices that tend to destroy the soil. And with the training, they would have more knowledge with how to properly care for the soil and grow their plants in ways that don't provide the need to find more soil. They would just be able to keep reusing it sustainably. I'm sorry, I couldn't quite hear your question. I would say that that would be part of the practices that they learned, part of keeping the soil healthy. So they would like about that in the training. Have to raise it when they want a more profitable crop that they could. It's just any farm in the region. it's just any farm in that region because types of farming and scale.
Yeah, just to add on, the Central Valley region is mostly small farms, but there are some larger, like agriculture, big farms. So we'd be mainly targeting small, like subsistence farmers, but we would also be interested in working with some of those larger corporations and finding ways that we could use this initiative to minimize their impacts. Yeah, so the control group we are basically leaving it untouched. Whatever current farming practices they have, they will be continuing those, and we're just observing kind of as a baseline, what are the people in the region currently doing? Is it working? How well is it working? And then we can compare it to education and then education plus high tunnel and kind of get a gauge on what the impact and what the difference in crop yield and sustainability actually is. So for the control, we basically are going to encourage them to continue whatever practices that they're doing already.
If you have multiple, if it's mainly small farms, but then there are a few larger, basically corporate farms, you might want to make a distinction between that in your design, impact evaluation design, because they're not the same across, right? And so, just something to keep in mind.
Personally, I have not gone, but I want to go. It's very famous for the tourism. I think it's ranked 5th in the world for tourism overall. So it's definitely on my bucket list. Don't know as of when yet, though. Yeah, it's already gone. Next one. Yeah, so Costa Rica is a little bit different because of their geography and their location. They have 2 main agricultural seasons. They have a wet and dry season, and so you're growing different crops depending on what season you're in. So it's mainly coffee or bananas or pineapples are their 3 main exports of crops. Thank you. All right, Julie.
Good morning. My name is Casey Killian.
And my name is Isabel Andrioli, and we're going to present to you on the analysis of PAHs in local lakes.
So basically, for a project, we were analyzing the concentration of PAHs within local lakes. For this one, we did Sportswood Lake. And so PAHs are pretty much aromatic rings composed of hydrocarbons, and they're known to be a cancer-causing toxin, and they can be very harmful to the human body and organisms. So lakes have been becoming very industrialized lately around like the little areas and the restaurants and the buildings. So due to this, we wanted to analyze if the pollution from tar runoff or from those local industrialized areas were running off into the lakes and whether the concentration of PAHs were visible.
We chose this project because we live in Lakeland Regional High School is in an area where there are a lot of lakes, and as Ren mentioned earlier, they are used for recreational purposes. People swim in them, people play games in them, and we wanted to see what these concentrations were doing in our lakes and how they were affecting the people swimming in them. So as Casey mentioned earlier, we went to Sportswood Lake, and we took in different, if you can see in figure 3, we took in different areas of the lake 3 types of samples from each part. We took water samples, sediment samples, and plant samples, and then we went back to the school. For the sediment and plant samples, which is what we tested on, we took them and dehydrated them. Then we mixed them with hexane and sonicated them and put them in a centrifuge, and we did that 3 times, and then we put them in the GCMS.
So for our results, we just started this project a few months ago actually, so our results aren't final. So what we found, we only ran the sediment samples and the plant samples, and from the sediment samples, we got a really low probability of any chemicals. We did not find any PAHs, which is a good thing. But for our project, instead, we found 2 other chemicals. Within the plant samples, there are only 2 chemicals that popped out. It was 4-teroxophenol and trimethylsiloxy.
The interesting thing about them is trimethylsiloxy and 4-teroxophenol, as Casey said, were found in plants. Trimethylsiloxy is actually a compound that is has a very low water tension and a very low viscosity, meaning that it thrives well in the areas that it goes into, which is the water. From what we've gotten so far, we can assume the fact that the plants are holding a higher concentration because when they are consuming the water to thrive, they're taking in these compounds and the compounds are surviving. Like, as we said earlier, the trimethylsiloxy doesn't break up easy, so it's getting into these plants and just holding on for dear life. And then going to 4-teroxophenol, it actually sparked another interest of ours in our hypothesis because it is found heavily in tire rubber. So it brings up the fact that runoff might be contributing to these concentrations of these compounds in lakes, because when you have tire rubber compounds left over on the water or on the road and the rain comes in and it runs into the lake, these compounds are staying in the lakes and not decomposing into other compounds.
So as you can see in the little diagram on the bottom, I believe figure 5, that was one of our samples run on the GCMS. So for that specific sample, we ran a sediment sample, and it's sort of low in font, you can't really see it, but there's a 9% probability of cyclohexane within the sediment, which is also a harmful chemical on lakes. So in the future, we're aimed at further studying these chemicals within the lakes and seeing if we could extend this to further lakes in our area to see if there are any PAHs and to expand our data. And also to change it to more of the bio side, we're also going to look at algae blooms like Ren's project.
Overall, we're really excited and looking forward to the future of this project because the results that we've gotten so far are supporting parts of our hypotheses, and we're looking forward to getting more results. No, we haven't thought of any solutions on how to get the compound, to ensure the compound wouldn't get into the lakes, but that's definitely something we could look at in the future in determining the lowering the concentration of it.
I know so we did have a symposium last week, and I know there was another group that was like trying to figure out a way to get rid of the polluting concentrations, and I think they used mushrooms for that. So that's also some way that we can explore this topic.
we're not sure how much they contribute to algae blooms yet because we haven't been to we went to the lake in the fall. So we would love to go again and see if we could get some sediments of algae or some samples of algae. But as we've seen, the plants have had a really high concentration or a really high probability of these different compounds. So potentially, maybe the animals who are eating these plants might be affected by it. But again, we haven't had any animal samples either. We've only had plant, sediment, and water samples so far.
Yes, this is also a communal lake. I don't believe you can swim in it, but I know people can fish in it.
You can, in most of the lakes near us, you're allowed to swim and fish. In lakes like Cupsaw and Erskine by us, I'm not completely sure about Sportswood, you're allowed to fish. I don't know if you're allowed to keep them or not, but you can swim.
That's something we would definitely look into, especially after we find more results and see if the concentration is high enough to be something toxic to the human body. Thank you.
Thank you.
Good morning, everybody. My name's Evan Connor.
My name's Natalie. Our project is on rodent models for chronic oral nicotine exposure and the psychological and physical effects of it. So the reason we want to do this project is because recently vapes are like, so nicotine is a common issue like nowadays of our peers, and not only that, of people consuming it. So we thought that it should be good to like kind of see what the effects of it, not only physically but psychologically, on mice.
So nicotine consumption is an epidemic among this generation, and vaping specifically and the effects of that on the amount of nicotine that enters the vapor's body. Not a lot of research has been done, as it is a newer thing that is being now a societal norm. So in order to model nicotine consumption in mice, to model human vapors, we have in each mouse's cage, we have 4 mice, 3 experimental, 1 control. We have 2 water bottles. One of them is a aqueous solution of nicotine. The other one is just plain water. So throughout the day, the mice they can choose to either consume nicotine or consume water. In order to make sure they actually start consuming it, to start, we will be adding sugar to the nicotine mixture, but they'll be able to actively choose throughout the day whether they want to consume it or not, and that'll actually allow us to show, by comparing their consumption of the nicotine water to normal water, their preference, and they will become addicted over time. So in order to actually measure how this nicotine is, the pharmacokinetics of that throughout their body, and to model humans, we'll be taking samples of their hair, as one of the main metabolites of nicotine in mammals is cotinine, which deposits in the hair. So we'll be taking hair samples. In the future, this phase hasn't been implemented yet, but we'll be running hair samples through an HPLC PDA in order to determine the amount of cotinine that's deposited. So that'll help us determine the level of nicotine that's actually spreading throughout their body after they're exposed, and that'll help us back with our water consumption data to see that they are becoming addicted and it's spreading throughout their body. Also, we in the future will be implementing blood tests in order to see the plasma nicotine levels to further cement this data.
We will also be testing them psychologically. We have a maze, as you can see in figure 1. And then we will also be doing a light-dark box test, putting them in the light part, and then having them run through it to see if they're stressed or not. And then we will also be running memory tests to see how it affects them cognitively. And we have the baselines for this to compare them to when they are being exposed to nicotine.
the maze and like dark box that we were talking about, they're actually the same ones that Claire's group have been using, so it works in the same way. So another phase that we want to implement once our baseline data is sound is a withdrawal phase. So after mice are exposed to nicotine and data shows that they have become addicted and it's circulating throughout their body, we'll take them off of it for 7 days and run tests again. So these psychological tests like the maze for their memory and cognitive function, also the like dark box for anxiety, we'll be able to see that like common withdrawal symptoms that are present in humans will be affecting the mice after a nicotine is taken away. And then eventually in the future, we hope to implement certain remedies such as like CBD, SSRIs, or traditional like antidepressants like that, that might be able to help ease withdrawal symptoms. And then this could eventually be applied with human patients. Also, we do have hope to extract potential other contaminants from the liquid used in vapes, so such as like heavy metals like cadmium and lead, and also other carcinogens such as benzene have been found to contaminate these liquids. So eventually we hope to extract them and then add them to the solution that we're giving the mice in order to get a more clear effect of all the different contaminants that people are being exposed to daily. Also, we do want to analyze their sleep. It's been shown that nicotine addicts, specifically from vaping, have had decreased time, duration, and quality of sleep. So we'll be using a GoPro to measure their activity throughout the night and see how long they're actually sleeping for. We'll also be using the GoPro with like a locomotor assay, which is a software you can download onto the GoPro that'll actually measure how far a mouse moves throughout the cage throughout the day, and we can also measure how long they've spent on the wheel, so we can measure activity levels. As nicotine is a stimulant, it is shown to increase their activity levels throughout the day in humans, so we're hoping to mirror that data in mice. Are we administering it?
We decided to do it orally with water bottles, so we will be putting a nicotine solution, mixing it, and putting it in water bottles, and we'll have one water with we'll start off with like 30
micrograms per milliliter.
yeah, in there, and we'll put sugar in it since it is bitter for them, so this way it's not like unpleasant for them to ingest, and there will be another water bottle in there, so they are choosing, so we can show that is like addiction, and we have been measuring their water intake, so yeah, we have been measuring their weight.
We'll also, as time goes on, we have plans to increase the concentration to 200 or 60 or 200 micrograms per milliliter. These are concentrations that are actually taken from the levels found in real vapes. So we plan to, well, our sample size is currently small, but we plan to continue to run testing throughout as we progress. We also plan to implement cortisol tests through their blood in the future to see if it has an impact on like their actual stress levels. And we will be running the test sort of a loop in order to get meaningful data, because we will need, with a biological study, you do need a lot of data to get meaningful results. And we'll be trying to implement solutions to remediate with withdrawal symptoms in the mice.
What's your name? Oh, here it is. Okay. Just a little one. Okay.
My name is Serena Diaurelia.
And my name is Lila Tanuzi.
We're testing the effect of selenium biofortification on nutritional yield of jalapeno plants. So what started our research is many people in America are lacking a balanced diet, which is one that provides all of the nutrients required by the human body. Wages are decreasing and inflation is rising, so many people resort to cheaper and less nutritional diets. Our experiment focuses on one nutrition, which is selenium. The largest amounts of selenium are found in meat, seafood, and poultry, which also introduces an issue with vegan and plant-based diets because they're lacking those foods that contain high amounts of selenium. The number of selenium deficiencies has also risen in Asian countries and places that have overworked and unfertilized soil. The amount of selenium in crops mostly depends on the amount of soil, the amount of selenium that's in the soil it's grown in. So when there's less selenium in the soil, there's less selenium in the plants. Our experiment aims to fortify jalapenos with soil, to fortify jalapenos with selenium, so that even if the soil's lacking, they can still get like selenium intake in their diet. Our method, we had two groups of jalapeno plants. The first one is our control, the second one is our experimental, and they had the same amount of soil and seeds in each. We watered them every 2 days with 10 milliliters of water, each plant. And we made a solution containing sodium selenite that was dissolved in deionized water, and we transferred it to a spray bottle. Once the plants are grown to a vegetative state, it will be sprayed onto the leaves every 2 weeks. Then they reach a reproductive stage, and the fruits will be removed, dried, and digested with nitric and perchloric acids. Each sample will be heated and filtered, and then analyzed using atomic absorption spectroscopy. The height of each plant stalk, the size of the leaves, and the mass of each fruit will also be measured.
We only tested on jalapeno peppers this time around, but in the future we hope to expand to other crops. Specifically, we hope to expand to crops that are common in areas with extremely high numbers of selenium selenium deficiencies. We also hope to expand to other kinds of nutrients, and by doing this, we hope to decrease the number of supplements that people are taking. Supplements are very common. Many people take supplements, but by fortifying plants with more nutrients, we hope to eliminate or decrease the need. We don't have any results yet. We have only started testing a few weeks ago, and we are starting a new batch. That's really it. We did research on this particular topic of biofortification, and we did come across studies dealing with both selenium and jalapeno plants. Yes. Selenium deficiency has many, there are many signs to it. Some particular ones are
excessive like tiredness or fatigue. I think that is the main sign of a deficiency. I believe it should take up to 8 weeks. Yes. Yes, we do hope to expand to include those in the future.